Today I'm going to talk about the chapter 13 and 14, temperature and heat. What is temperature? Temperature is what we human measure with a thermometer. The unit of temperature usually we use is Celsius and Fahrenheit. In the style we have another unit of temperature is Kelvin, is the absolute temperature. Normally we don't have the degree note in here. The Kelvin, so like if we call it like normally 100 Celsius or 100 Fahrenheit, but only simple 373 Kelvin, not in here. And here the relationship between the Fahrenheit and Celsius and Kelvin temperature. Normally we will compare with the boiling point of the water at the 1 atmosphere and at the sea level here. And what is heat? Normally in the normal life people will confuse between heat and temperature. Maybe it's the same, but in physics heat is a spontaneous transfer of energy due to the temperature different. It means the energy is the keyword here. Heat is the energy, while temperature is not. And the heat will be transferred from the cold to the hot or reverse. This heat flows. And the unit of heat is also different than the unit of the temperature. The unit of heat is joule in SI. There are some several another units like of heat like calorie or kilocalorie. One calorie is defined as energy needs to increase 1 Celsius degree of 1 gram of water. And what is temperature change? Temperature change only occurs when two things transfer heat to each other. It means when two objects maybe contact or any kind of heat transfer, the cooler object will increase their temperature or it be heated, while all the hot object will be low down their temperature or will be cold. What is heat capacity? Heat capacity because if we use the very hot water to heat up the metal, the master metal, we will see all the ceramic. We see the smoke of the ceramic contain the hot water. We will see that the hot water reduce temperature different than the increase of the temperature in the smoke, the ceramic. The reason why ceramic had a different heat capacity than the water. In definition, the heat specific heat is the amount of the heat necessary to change temperature of 1 kilogram of mass by 1 degree. It means heat to increase 1 kilogram of water by 1 Celsius different than the heat needs to increase 1 kilogram of copper by 1 Celsius degree. And we will have the equation of the heat transfer. Q in this case is heat transfer. And by definition, heat is transferred based on the temperature change, phase of the substance, and the mass of the system. Mass, heat capacity, and temperature change. Phase change. Phase change is different than the heat transfer change. In phase change, the temperature of this object, of item or of thing is not change. When the IQ melting into the liquid water, at this point during this process, the temperature of the IQ and the liquid water are only 0 Celsius. It's not change. And there are three kinds of the latent. So because the temperature is not changed, but they still need the energy and heat transfer to change its phase. So sometimes the physics call it the latent heat. There are three kinds of the latent heat. Heat for melting or freezing, Q equal to m times Lf. Heat for vaporization or condensation, Q equal to m times Lv. And heat for sublimation, Q equal to m times mass times for Ls, in which Lf, Lv, and Ls are correlated heat coefficients, which is different between the material. Yeah, something like the Cf quarter equal to 334 kilojoule per kilo. The energy of latent heat depends on two major factors: the number and the strength of the bond between atoms and open objects. Here is the graph temperature versus the energy added to here. For example, we have the temperature of a cube at the negative Celsius, 20 negative 20 Celsius, and we add the heat. We heat this ice. The ice will still be the ice where the temperature increases from the negative 20 Celsius up to 0 Celsius. But it is where the temperature is increased slowly here. But when it's melting, the temperature is not changed. But the water changes from the solid into the liquid, different form. When every ice is melting to the liquid water, the temperature will continue to increase if we continue to add more heat here. And then when it reaches to the 100 Celsius of boiling point of water. Right now, the temperature still no change. But the water we move from is the liquid form into the air gas form, steam. And when all the liquid water transfer into the steam, the temperature now increase continuously. That's all the graph temperature of the energy air. When how the water changes form, changes phase, and increase the temperature inside during time. We have several problems here. The first problem is we have the pure material, and which is 0.25 kilogram, and increase from the 20 Celsius to the 65 Celsius. We need to add to the 4.35 kilojoule. So we have the Q equal to mc density. Indicate Q here. Joule equal to mass here, kilogram, and C we unknown, times 55 minus 20, and then we can find out C equal to a simple calculation. And maybe it could. The second problem is a bad content ice is the 0 cells much more effect than absorb energy than one contain the same amount of water. Now calculate first with the A cells we have also u q of water equal to mc water times to delta T. In this case, water is 0.8 kilogram times to the physical capacity of the water around 416 times 43, 30, and we have 1004 joule. For the ice, Q of ice equal to Q of melting, with a Q of water. It is the same here, but Q of melting equal mass LF. Mass is 0.8 kilogram times 334,000 by calculating. The last answer is here. So we see the Q of ice, Q of water with the same temperature. We can see it's nearly 3.66 times. So the bag contain ice is more effective to absorb energy than the bag of contain only liquid water. Okay, in this question we use CF for the final temperature. And the final temperature we place around here from the negative 30 Celsius to the 35 Celsius. Maybe it's the here. And we have V ice plus 3/4 equal to 0 in the case. For the V ice equal to V ice plus 3I V melting plus V water equal to M C ice times delta T1 times M ice times F the water plus M ice C water T finals minus 0, and we will have that something like 5 times 0, 9, 8, 20, 5 times 2, 3, 4, 5 times 1, 6, 6, TF equal to plus TF equal to Q of what in this case equal to M quarter times C quarter TF minus 35 Celsius equal to times 4.86 1674.4 minus 6.04. 5, 3, 3CF 16744 CF 0 and the sensor with the final answer. That's all. Thanks for listening.